Hello?
Hello. Hi.
Hi.
Hey, how are you doing today?
Good.
Awesome. So, we'll start with the introductions. Then we'll jump on to the coding question. And if you
Okay.
get through that question, we can then try doing another one.
Okay.
Does that sound good?
Yeah.
Awesome. Yeah. So, I'm a backend distributed systems engineer. I basically work in one of the cloud-based internet companies. Yeah, that's all. So, do you want to introduce yourself?
Yeah. I'm a rising junior in college, University of Pennsylvania, studying computer science. And I'm preparing right now for coding interviews for the internships I'll be applying to this fall for the summer after my junior year. So yeah, that's where I'm at. I've been practicing pretty intensely for the past month or two, I would say. But I have a fairly long history of doing coding projects and studying. I'm studying computer science, so I would say I'm at an intermediate level.
At the intermediate level. Awesome. Yep, that sounds great.
Okay.
You will. I'm pretty sure you'll be able to get your more than one internship coming this term. So best of luck for that.
Thank you.
All right. So for today's coding question, let's suppose you are given a list of positive integers, and we want to check if it is possible to break that set or that list into two subsets, such that the sum of both the subset is equal.
A sum of did you say positive integers or?
Yeah. So for example, I'll just write it out here. Suppose your set is something like this. We just want to make sure that if you sum it up this set, this becomes 12 to 14. So is there a subset which can sum up to 7? So in this case, I say if I break it into this way, like one subset has 4, 3, and the other one has 5, 1, 1. So we know that it is possible to break it in such a way that the sum of both the halves are equal.
Okay. So I'm thinking the first thing is if we sum up all of the numbers in the set, we get that total. Then we're looking for any subset that matches the total divided by 2, I guess.
Yep, that's correct.
Okay. All right. So I think one strategy here would be to write a function to try and find a subset matching a target value. And I guess our top level function will just use that function and pass in the sum divided by 2. And I think the way I would go about implementing that function to find a subset summing up to a target value is, so I think if we have a table where the rows correspond to the target value if it's a positive integer, and so that those would go from 1 to the sum divided by 2, I guess, and then the columns would correspond to a slice or a partition in the list, and we can assume that we have access to the elements up to and excluding that index, and then I think there should be a way to kind of express the optimal value kind of in a bottom-up approach, go iterate through the table and set each entry of the table using the values of previous entries. So that's I would say that's the main approach. That would be I guess if S is the sum of all the elements in the list, then the complexity of the time complexity would be um, like O of S times N, where N is the length of the list, um,
Mm-hmm.
and the space complexity would be the same. So I'll try and implement that. Um, so actually, let me see. Um, yeah, so I'm thinking um, the table is initialized to, this is just initializing each of the rows, but where each row only has one element to start with. Because when the column is 0, that means that um, our slice of the list is like empty. Actually, I guess I should think about what's in, about the contents of the table. So it's going to be like, I guess like a Boolean, indicating whether, um, hmm, indicating whether that there is a subset of that section of the array which sums to that target.
Mm-hmm.
Um, so yeah, I guess like if the target is 0, then it's going to be true, but for all others, it's going to be false.
Right. So how it
Uh,
will help you in figuring out whether, let's suppose, even if you have a answer for a subsection of your input, like is there a way I can use that to build my answer further? Because in this case, it will only tell you like this is not possible to reach up to target, but it wouldn't indicate in any way that if I can use this information to deduce that if I take further elements, will it help or not?
yeah, that's a good point. So I think maybe, hmm,
Is there any merit in storing just the sum? Like if I can use, okay, you summed up to x and I am, let's suppose, 5. So I know if I include myself, I'll be x plus 5. That may or may not match my target, but at least I'll be able to deduce what is possible using what that information.
yeah, that's a good point. Well, I guess like, would it be maybe like the closest value to the target? Because then like there is a way to say like whether, when you're taking a step, I guess, should I include this new element or not? Like if it gets you closer to the target, then you should. Um, and then like if it's feasible to actually reach the target, then the value will equal the target, and then you can say it's true. I'm
Right.
not
So going back to one step further, if you're saying we will take the element if it takes you closer to the target, but that condition will always be true because you have positive integers. So you'll either get closer to target or you'll overrun it.
right. Um, but yeah, I guess is that a problem? It doesn't seem to be a problem to me because like um, hmm.
Yep, shouldn't be a problem. Just wanted to
Yeah.
make sure that.
Sorry, what did you say?
I think yep, shouldn't be a problem if you use it in indicate to this way. Like you can maybe explore both the path and see where it leads. Because you only have to check does any one of these paths leads to having that target achieved. If it is, you are done. If it isn't, then you know for sure that there isn't a way to achieve that.
Yeah. Um, so yeah, I guess it isn't like say like even if the first like three numbers, you know that the like I don't know, say the target is like well I guess with these first three it's kind of not a good example, but like the first like however many elements of your list, if you knew that a subset of them summed to some number and that was as close to the target as possible. I guess the problem is when you're taking a step, it's not just a constant time thing to check, um, like because when you're including that new element, I guess um, it could be the case that the subset of the previous uh, elements would be different.
That is
Oh,
true.
but I guess it's like since you have the table, like what you want is the subset of the previous elements that's as close as possible to the target minus the element you're adding. And if that number is closer than not including that element and just including like, okay, it'll be, I think I have some sort of idea for how to implement this. So I'll try and like explain it as I'm going, and hopefully it'll work out. But I guess I'll see. But yeah, so then it would be zero for all these, and then I'll say like for um, like I guess for partition in range, actually the partition will be just in range like the length of the array plus one, and then we'll say um, for target in range then like so I guess the actually maybe it's a better idea to go like this. So then in this like here we can just append to the list, and then basically like t um, or so the new element that we're considering adding is array partition minus one,
Hmm.
and so we'll say like the closest like value if we include it would be t of um, I guess like oh and yeah up here we can say like if s
Yep, that's a great addition.
I'll say like final target is s divided by 2. So the final target is what we're trying to like achieve
Correct.
with a sub. And then so closest if we include it would be final target minus new element, and then and then it would be partition minus one. If and I guess we have to check like um, if this is greater than or equal to 0, else I'll just say negative infinity. So it's like yeah, actually, well, I guess it's not. Yeah, because like if the optimal value for like a target being final target minus new element, partition being partition minus one, if that or I guess if final target minus new element is less than 0, then it could be that that
You
I guess like if we were actually solving the problem where we're trying to get as close as possible, then we would want to like consider that case. Like maybe it's better to be if it's overrun slightly, then that's closer. But I guess we don't care about that case because it's always going to be false in that case.
right?
So
Yep.
we want to if it overruns, we want to just ignore it. And yeah, I think that should be good. So and then closest but it's so it would be that plus new element. And then if we don't include it, it would be just that. And we don't need this case. So then we can say T of target partition equals closest if not included if is less than and actually I think this should be target. Yeah, so and then at the end it would like return T of final target length array equals final target. So I have to like review this to see. Okay, so yeah, so one thing that we have to do actually is because the way we set up the table, we have to append instead of setting. And then let me see. So closest, if we include it, then the closest we can get is like whatever the optimal subset was to reach the target minus the new element using only the values from like the partition minus one subarray, and then you add new element to that like closest sum. If the if new element is less than or equal to the final target, and if new element is greater than the final target, then we definitely don't want to include it.
Yep. So it's a false. Like including it wouldn't really give you the answer in that subset.
Right. And so yeah, so in that case we just say like the closest sum is like negative infinity, which is or infinity would be fine. Like it's not going to be it's going to choose closest if not include either way. And then if we include it, it's just the same target. Actually, okay. So yeah, just to make sure I didn't. Okay, yeah. So if the target minus the element is greater than or equal to 0. And then if we don't include it, it's the same target and just partition minus 1, and we're not adding anything. Then we say the row corresponding, like the target row, append closest if not include, if that's closer than closest if include, if that's closer than closest if include. And I think because we're saying like it's always going to be less than the target, we could do like target minus closest if not include. That would be fine, I think.
Yep. Do you want to like call this method from a function and just run it on some?
Sure. Yeah. So let's see. So this one should be true.
Yep. This one should be
or
false. Sorry, this one should be true. Ignore me.
So 43511. And then I'll do like I guess at the end I'll do some edge cases, like the empty array technically is true, I think, because I mean, I think like the trivial sum is generally considered 0, so you could split it up into like two empty pieces where they both sum to 0.
Yep, sounds good.
And then just like that should be true. And that should be false. That should be true. So I'll just run these and then see from there. Oh yeah, my bad. I put these.
It's a bracket, yeah.
Okay, so it looks like it matches in those cases.
Yep, it seems to be matching pretty much everything. How about we test it with a single input? Just have one which has only one input, say 5.
Okay, yeah, so that should be false, unless it's 0, but I guess we're assuming positives, so
Alright,
false.
can you change this 1 to 0? Line number 31?
Yeah, sure.
In this case, it should be still false because there is technically only one element and you can't really bifurcate it.
Oh, I think. I mean, I think if you consider like so if this case appears true, then I think this should be true also, because like the subset was containing 0 and then the empty subset, you would say.
Right, I think, that makes sense. Because you're technically saying that all the members of your set is in 1 and the another is just an empty subset. So from the perspective of sum, they both still sum up to 0. Yeah, I think that is fine.
Oh, yeah. So I forgot to change that. That should be true.
Yep, so it checks out. You got the complexity right as well.
Nice. Wait, did that run? Not sure.
Yeah, it's a bit slow. Okay. So this works. This is great. Now let's suppose we also wanted to figure out that subset which sums up to sum. How would we change this to also print that output?
Okay, so I think the way we would do that is and just like print it out as like a side effect.
Yep. So like we asked this function to only tell us whether it is feasible or not. Now we want to know if it is feasible, then return the answer. Otherwise, return false or just return an empty array.
Okay. All right. So I think like Okay, so at the end I'll say like if it doesn't match, then return none. And if it does match, then so I think we want to say like target equals final target and partition is the length of the array plus 1, and then like while target is greater than or equal to 0, or actually, well, yeah, so I may change these conditions later, but partition greater than or equal to 0, we'll say like we'll kind of figure out whether we included or didn't include that element. So, I mean, we can just kind of copy this logic again. And so, and this condition. So, or I guess we should say if yeah, so if not include is less than include, then we append the element. Or I guess we can include this as well. And then once we get to, yeah, so I think we actually have to have target we have to have partition greater than or equal to 1. And then, yeah, so then at the end, we'll say, and should I return like the,
Just one list which have any of the answers. Because there could be potentially multiple answers. We are just looking for any one.
Okay. Yeah, so I'll say like first subset and second subset. So first subset that append.
Like one is fine. We're just only concerned about one subset.
Oh, okay. And then, yeah, we can just assume that the remaining.
Others are, yeah, the remaining is whatever is not included. So.
Okay. So, and then we would return matching subset. So I believe that should be good. This condition is just basically matching the like start conditions of this, and everything bound partition -1 is positive, and yeah. So I can run this and see. Okay, so partition -1, line 25. Oh yeah, partitions should start at the length of the array. Okay, so yeah, we forgot to update target and or I guess we can just say the partition is going to be minus by 1 no matter what. Okay. Matching subset. Interesting. So let me just print just to debug here, let me just print these two values, see what's going on. So in the first example, I guess I can print like the target first. Okay, so yeah, in the first example, wait a second. The target is 7, which makes sense.
The target is like decreasing pretty well. If you see the 7 to 1, it means it did found something and then it is moving in the right direction. Like, where is it not adding the element which we just considered to get to this sum?
Yeah, it seems like at every time it's just saying to not include each element. Like, but it doesn't really make.
Oh, okay. So our condition says closest if not including target is less than closest if including target. So think about it. Is this condition like necessarily true in every situation? Like you may have two elements. For example, suppose you are starting from 10. You have one element 3, other element 5. When you subtract 3, you get to 7. When you subtract 5, you get to 5. But it could have been possible that your answer would have been in the set which you reached to by subtracting 3, depending upon the other element. So it is not necessarily true that only the elements will take you closer to the target which will lead you to the final answer. I hope I'm making sense.
Well, I feel like this is just like replicating the logic up here, like, because if closest if include is the same thing, it seems like, and closest if not include is the same. So like the whole, I guess.
So in the above example, you're going from like 0 to 10. So
yeah,
no matter what you'll include, it will take you to the closest.
If you include, it'll always take you to the closest.
Like you're moving from 1 to 100, so no matter what element you pick, guaranteed like everything is a positive, you will be moving closer to it. But when you're traversing backward, this condition may not be true. Like it may not be yield you the answer.
I see. Yeah, but I guess like regardless of like the direction of movement, like at any, so like for instance, when at this first iteration, here I can even print out like here, like the target partition, because I'm thinking like at any individual iteration, like the values are the same, right? It's just like the way you change the values. So I'm not totally sure. Sorry. Oh, and I have to, yeah, add like.
I think you can just comment out the other print statements, or maybe just work with one example. It'll be easier to follow.
Well, yeah, I was trying to like compare them, I guess. So yeah, like for instance, when in this like first section, like when the target starts at 7, partition 5, and if we like compare that here, like 7 5 7 7, that should match. And then like it goes to 7, 4, and then here 7, 4. Yeah, wait. Or like here, I guess. Like 7, 1 is closer to 7 than 0 is, right? So in this
1 is
last,
closer to 7 than 0 is. Yep, that is true.
so then like in this iteration, it should like closest if not include should be less than. I guess like I can even like print out like the distance to the target, the absolute distance to the target. Let's see. Yeah, so in this last iteration, it's like 1, yeah, wait, did it? Okay, so in this last iteration, absolute value of closest if not include minus target is 7. Absolute value of closest if include minus target is 6. And so,
So you will be taking the path of 6.
oh,
Right, and I'm saying that may not be the path that lead you to the answer.
well,
So there could,
I'm not sure this is the reason why it's always empty. But I'm pretty sure, yeah. So like if the distance of the if not include is greater than the distance if include, then you should add. But yeah, I don't think that's why, but um, oh, huh. For some reason that was, that's my bad. For some reason that it seems like that was the issue. I guess because yeah. So now it seems to be working. It was just it's like the inequality was flipped, right? Like closest if not include, like this is like the distance to the target. So like you only want to include it if the closest if include is closer. But I guess the reason why that messed it up is like if closest if not include is closer than oh hmm. I guess because it's always going to be closer to include something. Yeah.
in the
So
first
that's why
example, can you add one more? Like add a comma 1 in input,
in,
line number
in
35.
sure, yeah.
Just wanted to see, just one second. Okay, so it is saying false, which
Yeah.
is correct because there is no way. Can you add one more? Like add put comma 1. Yep, that checks out.
Yeah, yeah. I didn't realize like the optimal path I guess will always involve like including stuff because it's all like positive integers and it's like a subset you're trying to get to a sum. So like this one bug where it was like flipped, where it only appended if you're not supposed to include it, actually just caused nothing to be appended. So it was kind of a weird bug, but yeah. So I think it's correct now.
Awesome. Yep. And I think described the time complexity of the and the space complexity correctly for this solution. So how about if we try to, let's say, reduce the space complexity? In what direction we could take steps?
Okay, so yeah, I guess like it's always only using the partition minus one
Hmm.
column. So I think what we can do, um,
You don't have to implement it. Just want to discuss it and say.
okay, yeah. I mean, we can just include like save the column instead of the whole
Hmm.
table, and then just replace the column at each, like make the partition the top level loop, and then replace the column at each iteration. And then the space complexity would be reduced to O of n as opposed to O of s times n.
OFS.
Sorry, O of s, yeah. There would be n different, yeah. So O of s.
Yep, I think that makes sense. Yep. So, yep, I think that was the all the questions I had for this interview.
Great. Okay. Well, thank you.
Awesome. So I'll get to the feedback. So first of all, you've done very well. I think you must have realized by now. I used to ask this question when I actually conduct an interview for my company. Less than
Uh,
5% of the candidate is able to get to any solution. Able to get to an optimal solution is less than 1%. Able to get to a follow-up is you are talking in 0 point something percentage. So from my point of view, you did pretty spectacular. Like I would give you a strong hire, the best
great.
possible rating. You were able to see through the problem, like to understand it what it was. You were also able to see that you put an early optimization as well, that if sum is not even, then you know it is not possible. So that was pretty great. Then your approach was pretty good to tackling the problem. You ran through an example, you quickly coded it, and you were also able to run it. So, yep, like all in all, pretty well.
Great. Yeah, I think I guess usually I'm faster at like debugging stuff like that, but that was kind of a weird bug that came up. But yeah, I guess um, that's well. Thank you for the positive feedback.
Yep, no worry. I think you debugged well, and it is expected that there will be some sort of null location, and you can't really debug it perfectly just by one thought. So I don't really mind you trying something and see if it makes sense, and then going back and revert it. So at least from my perspective, I wouldn't hold it against you or for that matter any candidate. Yep, your execution speed was also fine. Like once you had an idea what you wanted to do, you were able to convert it into code. So that gives me a pretty strong signal. Even if you, for some reason, you wouldn't have been able to solve the problem, I would have still given you a higher at least, if not strong higher. Because
Awesome.
what I was really looking for the interview is not whether you can arrive at a final solution or not. Whether like once you have an idea what to do, are you able to write code for it? Bugs and all is I think still fine. So
Okay. All right. Well,
awesome.
thank you so much.
Yeah. So do you have any questions for me or anything you want to ask?
Well, do you have any advice for someone in my position? I'm trying to prepare for internship interviews and stuff like that. And I guess the summer's like around halfway done, so
Mhm.
I'm gonna continue preparing as much as possible. But do you have any advice?
I think from the coding perspective, you are pretty through the bar. You'll easily get an offer no matter where you decide to interview. So keep doing what you're doing. That works well. Proactively reach out to the companies who you are targeting to. And once you get to an interview stage where somebody can like actually interview, I'm pretty sure you'll be able to get through it.
Nice, yeah. Yeah, I guess that part of the challenge is actually getting like an interview. Sometimes um, I guess I'll work on my resume and all that to try and get to the interview stage. But yeah,
Yeah. So
um,
I work in AWS. I don't know how they select folks for interview, but if you want, you can forward me your resume, and I'll try to see if there's somewhere I can refer you. I can refer folks for the full-time position, but for the interviewing, I'm not sure, but I can check with whoever is in charge and see if there is a way I could refer you because I would love to
oh,
if
that'd be
you're
awesome.
interested.
Um, yeah, I'll definitely do that.
Yeah, so let me check out with some of the folks who were an intern and then got full-time hired. If there is some way to make sure they have an HR contact or some portal to refer you, but we'll do that. Sure.
Okay.
Awesome, man. Yeah, just keep doing it. Your coding skills are super good, and you are able to solve most of the problems. So, pretty impressed, I would say overall.
Thanks. Well, have a great day, and thank you for
Yeah,
your
you
time.
too. Yeah, have a great day ahead. Bye.
All right, bye.